In this video lesson, I'll go over how to do the next 3 labs. If you already have 15 labs, there is no need to do these labs. And you do not need to do all 3 of these labs. You just need to do enough until you have 15. This video will go over how to access these 3 labs and how to do each one. So first, go to this website and create an account using this code here. So this information will be on the video description. If you do not know how many labs you have, check Jupyter, the number of labs. That will be the number of labs you have. Okay, so you can enter your name, last name, your user for the account, password, and confirm the password. So after you created your username and password, you must also create 3 questions with answers. So take a moment to do that and click continue once you're done. After you made your account, it should look like this. Make sure you wrote down all your information on a piece of paper, your account and password. Now to access the game, you're gonna Google Chemistry Collision game. So I'll leave the link on the bottom of this video so you can access it. So you can then click play the game. You then will get on this website. You can then log in with your account information. So the account I made. Okay, so once you log in, it should look like this. Now go on Jupyter under the assignment for virtual lab collisions. You're going to download the corresponding lab. I uploaded 3, one for atoms, ions, and covalent bonding. Okay, so it should look like this. So for atoms, if you download the atom quest, it should look like this. So these are fillable blanks of the PDF in which you can write your name, as well as fill in the answers. This is for ions. So you can download the ion one. You want to do the ion one. And the last one is the covalent bond one, which is a Word document. Okay, so let me show you how to use this site. So this is expand, right, for full screen. Over here is basically you can log out, and this is your account. Okay, so now I'm going to show you how to do the first lab. I will put time codes on the bottom of the video description in which you can jump from lab 1 to lab 2 to lab 3. Okay, so again, you do not need to do all 3 labs. Just do enough until you have 15 labs. So let's start with the first lab, the atoms. So atoms, you see this T here? It stands for tutorial. That means they'll show you how to do it. And there's 13 parts to this game. This over here is sandbox. That means you could do whatever you want in this. It's just for extra practice, technically. Okay, so clicking this will shrink the screen again. So for the document you download, you're gonna write your name and leave these blank. Make sure you download the right one. This is for atoms. So here is an example on how you're gonna do it. So basically, you're gonna write the atom on the screen. So let's say it was chlorine, and the information about chlorine, like how many protons, electrons, and its properties. For electron configuration, you can just use the periodic tables configuration. You do not need to use the SPDF ones, so you can leave them out. Okay, you can just use a simple one. Okay, so notice on the top of each page, so this is page 2, it says challenge level 6. So notice you must do 5 tutorials before you can reach challenge level 6. Okay, so after you reach level 6, that's when you can start filling these things in. Okay, so I'll show you how to do the tutorial up to challenge level 6, and you should be able to do the rest yourself, right? Because it's really straightforward afterwards. It's basically the same questions, there's different elements. Okay, so let me expand. So let's go to, so you cannot skip. Okay, so you gotta start at level 1. So during the tutorial, they'll teach you how to do it. So they're telling you this red one is the proton, This is basically where you can create your nucleus. So click, and the proton will go there. This is the electron, and this is the orbital. If you click the orbital, it will go there. So swipe left means to drag left. Now swipe up means to drag up. So the reason why they're using the word swipe, because this is basically a game on the iPad, right? But you could play it on the computer if you want. So you click this, now you drag it there, and you're basically done. That's level 1. Level 2. So here you're building a different atom. So tap this twice to add 2 protons. So you have neutrons as well. Now you're going to add electrons. So you do the same thing. You drag, you make helium. So click this and it should say complete. Level 3. So this isn't difficult to do. Okay, now this is the first shell. So you're going to put 2 electrons. The orbitals fill. So this is the second energy level. So you can see you have your s orbital, and these are your p orbitals. If you recall from the last term, there were 3 p orbitals, right? So you just click one, then you just put it back together, and that's basically it. That's boron. You click, and you're done. Level 4, orders matters, Hund's rule. If you recall, Hund's rule is when in a sublevel, when you have multiple orbitals, you fill the orbitals by single file first, then you could double them up. So let me demonstrate what that means. So here we have 8 protons. Let's build the atom. Now, we gotta add 2 electrons to the first energy level. So this is the second energy level. We have our s and p orbitals. Let's add 2 to the s. Now, in the p sublevel, we have 3 p orbitals. So we can add everything by single file first, then we double them up. That is Hund's rule. Once you're done, drag it, and we made oxygen. So in case you made a mistake, you can click restart level, and you can restart the entire level. You're not restarting the entire game. You're just restarting this level in particular. Okay? Now you drag it, and you're done. Okay, so let's build one atom first. So remember not to use all your protons and electrons. So let's build 4 first. So that's beryllium. Now let's build the next one. And 1, drag it back down, and boom. So now it's saying it must be ordered from the smallest to the biggest. So boron, if you look at table S, is actually smaller than beryllium. So you drag it, and you just switch them. And that's it. Click them, and you're done. Okay, now we're on challenge level 6. So now this is where we can now start entering stuff for our challenges. So now for atom 1, so we gotta make boron. So boron is already made. Now you gotta make an atom smaller than boron. Alright? So, and we're given 10 protons and 10 electrons. So you recall, the more protons in the nucleus is gonna pull electrons closer, right? So you wanna make an atom that has more protons than boron. So let's use 6. So that's 6. So that's carbon. We're good. Now on our page, I'm gonna put carbon. So you type in carbon, and we have 6, 6. And that's it. Now we enter the element's name. That's carbon. 6 is atomic number. Average atomic mass, you just look up on the periodic table. I believe it's 12.0 something. So you just look it up on the periodic table. So look up periodic table for that one. Number of neutrons, that'll be 6. Carbon is a non-metal. Electron configuration carbon 2-4. How many valence electrons? 4. The group name, so basically just write the group number, so group 14. Number energy levels, there's 2. Numbers of unpaired electrons. So how many electrons are unpaired? So let's look back. To figure that out, notice there are 2 electrons that are not paired up in the orbital. So just write 2. They're not, there's only by themselves. If you look over here in the orbital. Okay, so that's carbon. Let me do the other, oops. Oh wait, I definitely put some by accident. Okay, so let's put carbon back together. Now let's make this one over here. So this is beryllium. So very good. So now you're gonna basically do the same thing here and type in beryllium, number of protons and electrons, and you're gonna fill in the rest, and you're gonna fill in for boron as well. So that's basically how you're gonna do the lab for atoms. And basically, you just continue on your challenge. So challenge 7, and so on and so on. Basically, it's the same thing, just more and more difficult, elements. So that's basically concludes the tutorial on how to do the lab for atoms. Okay? So basically, you want to go back to the main menu. You could go click main menu to go back, and you can do another lab if you wish. This will save your progress, just don't lose your account. So now I'm going to show you how to do the second lab for on collisions. So the second lab is for ions. So there are about 15 levels for this lab. You do not need to do all 15 levels. So again, T is for tutorial. So basically, make sure you download the correct PDF. It should say ion. Write your name. You can leave these blank. Here's an example of how to do it. Okay, so unlike the other lab, you do not need to go to a certain challenge level to complete this. You could just use challenge level 1, 2, 3, 4, as long as you fill in the information, because every single question is basically the same. Okay, so there's no need to fill this in once you're on challenge level 9. You could do it at challenge level 1 or 2 if you want. So let's do this. So this is creating a positive ion. So here's sodium. So it tells you how many protons and electrons it started with. Now you gotta drag. So notice you're using energy to remove this electron. Now it tells you how much this ion has now. Yes, still has 11 protons, but it lost an electron. Now once you're done, you just drag it, and it tells you charge, and the valence electrons, which is 8 now. Again, if you're stuck, you can click this, and it'll show you how to do it again. Now, so how to fill this in? So we just did sodium. Charge is positive 1. How many protons the sodium had? At 11. We lost 1 electron, so we have 10 now. And we use energy. So what's the ion name? Sodium ion. The type of ion, cation, which is positive. It lost electron. The formation reaction, so basically sodium, arrow, became sodium ion. So sodium plus an electron. So since you used energy, was it endodermic or exodermic? If you use energy, it's endodermic. If you release energy, then it'll be exodermic. Now, was the ionic radius bigger or smaller than the parent atomic radius? So it's going to be smaller in this case because you lost an electron. You lost a shell. What noble gas is isoelectronic with this ion? The word isoelectronic means the same electron configuration. Okay, so sodium ion, if we look back at this picture, right, is now 2-8. Which noble gas has the same configuration? That'll be neon. Neon is 2-8. Okay, so I'm going to do one more so you just can understand how to do this. So let's move on to the next level. Um, I'm going to do one more. Okay, let me go back to new level 2. Okay, so for level 2, you're going to be creating a negative ion. So we drag fluorine, tells us it's neutral. Now we're going to add an electron, fluorine, and energy was released. Now we drag it, and we're done. So now we can fill in our PDF. So we just did fluorine. It's -1. We had 9 protons. We gained 1 electron. And energy was released. So click the release one. Now, you recall nonmetals for the base name you keep, but you change the ending to IDE. So this is fluoride ion. It's an anion because you gain electrons. Formation, so it'll be F plus 1 electron, give us fluoride ion. So this is exodermic because you released energy. Now, ionic radius greater or less than the parent's atomic radius. So anions have larger radius than its neutral counterpart, so it'll be bigger. Now, which noble gas is isoelectronic with this ion? So fluorine, if we look at fluorine, it is 2-8. So the one with the same configuration will be neon. And that's basically it. Now you move on to the next level and you finish the rest. And that's basically the entire lab. Okay, so now I'm going to show you how to do the dirt lab. So very few people will have to do this lab. It's the covalent bonding one. So there's 17 levels to this lab. You do not need to do all 17. So let's first download the covalent bonding worksheet. It should look like this. It's a Word document. So whenever you see these red texts, that's where you can enter your responses. So main, write your main. Again, if you need to edit, just click it and you can edit your response. So here's an example of how to do it. So here's going to write the number of bonds, the chemical formula, main, the Lewis dot structure, you're going to draw it, the shape, the angle, and the formula mass. So you're going to do the levels until you reach level 4. That's when you can start filling these things in. This lab goes up to level 15 or 14. So you don't need to do all 17 levels. So let's do the game. Let's start at level 1. So here's fluorine. These are the valence electrons. So valence electrons want to be paired. So this is paired, this is unpaired. So we must share to make a pair. Now we made a covalent bond. Now for chlorine, so we rotate to make a pair. To unbond, you double click. Now to rebond, you just drag it. Okay. Here they want us to make another one. So this one is fluorine and chlorine. Now they're paired. But whenever you see one pair, that's basically one bond. One single bond. Okay, now for level 3. A hydrogen only has one valence electron. So now we're going to bond them together. And we made one single bond. So oxygen has 6 valence. We need to make 2 bonds. That's 1 bond, 2 bonds. That's water. Okay. Okay. So for level 4, now we can start filling in the worksheet. Okay. So let's fill one of them in. So let's start with sulfur, hydrogen, hydrogen, and that's the first one. So we have basically a bench shape. So we see 2 single bonds, 0 double, 0 triple. Type in the formula, you type H. So here's the subscript. You click this to S. For the molecular name, if you forgot, look up the rules again, or you Google the name for H2S. This is hydrogen sulfide. To draw the Lewis dot structure, click Draw on your Word document, click one of the markers, and you can start drawing. Now for the lone pairs, the sulfur has 2 lone pairs. You look at it. 1, 2. Okay. So you can always drag it back up if you want to look at it again. So it's 2 lone pairs. Okay. Now for molecular shape. So click this to stop drawing. So in case you forgot the molecular shape, you can look up the table of molecular shapes on Google and you try to match it to the best of your ability. So H2S is a bench shape. It has 4 electron dense areas. The bond angle of bent is 105. So again, if you forgot the angles, look them up. Okay, now let's do target 2, which looks like this. So which is this one? So we're going to use so we made NH3. Now, so NH3 has 3 single bonds. 1, 2, 3. 0 double, 0 triple. So subscript 3. Molecular name is ammonia. Now we draw, click pen, and we can start drawing now. N, H, three, ammonia. Click this to stop drawing. The molecular shape of ammonium is trigonal pyramidal. And the bond angle for trigger perimeter should be 107. Okay, so now that concludes the tutorial. So once you're done, you can move on to the next level and you can fill in the rest by yourself.